Okay, so the last standard that we're going to be looking at is standard 9, Pascal's triangle and the binomial theorem. Just a quick reminder that in order to form the Pascal's triangle, we're always going to have ones on the outside. And to find the interior numbers of any row, you're just going to take two numbers, add them together to get the number in between them. So 1 plus 3 is 4. 1 plus 2 is 3. So if I wanted another row down here, 4 plus 6 would be 10. The row represents the number of terms. So we got 0, 1, 2, 3, 4, etc., etc. So, and really a better word, not number of terms, but the degree of the polynomial. So that's actually, let's change that to degree of polynomial. Okay? And so the degree of the expression that is formed by these lines in Pascal's triangle. We'll get more to that in a minute. Another thing that we need to know, which is in the formula book, is something called combinations. Combinations is basically taking n items and taking them r at a time. Okay, so there are two ways of writing this. We can write it in this format right here, or a little bit newer format, which looks like this: n items taken r items at a time. The formula, which you'll find in your booklet, is n items chosen r at a time is going to be n factorial, and we'll talk about factorial again in a second, over r factorial, n minus r factorial. So a quick example: if I have 4 items chosen 3 at a time, that's going to be 4 factorial over 3 factorial, 4 minus 3 factorial. So that's going to be 4 times 3 times 2 times 1. That's what factorial is. Factorial just means start with that number and then keep reducing down to 1 and multiply all those terms, all those factors. 3 factorial is 3 times 2 times 1. 4 minus 3 factorial is going to be 1 factorial, or just 1. I simplify what I can. 3's, 2's, and 1's go away. 4 divided by 1 is 4. Now what I'd like to do is compare that to what's up here in Pascal's triangle. When the degree is 4, which is basically what this is saying, it's 4 items. On the row down here, what we could look at is, this is our r's. R is 0, 1, 2, 3, 4. So if I have 4 items right here, taken 3 at a time, the result is going to be 4. So that's how that kind of connects to that piece right there. So this is our answer for that question. Okay, so there's a basic example. We're going to take a look at one more. Find the value of 7, choose 5 at a time. Okay, so we're doing combinations of using 7 items, but we're only picking 5 at a time. So 7 choosing 5 is going to be 7 factorial over 5 factorial, 7 minus 5 factorial. So I just write it out. 7 factorial, 7 times 6 times 5, 4, 3, 2, 1. 5 factorial is 5, 4, 3, 2, 1. 7 minus 5 is 2, so that's 2 times 1. And the same thing. So all the green ones matched up already. 5, 4, 3, 2, 1s are all gone. 6 over 2, the blue ones right here, become 3 over 1. And I'm left with 7 times 3 in the top, all over 1. 7 times 3 is 21. If we compare it down here, I'm going to get all the way, so here's n equals 0, 1, 2, 3, 4, 5, 6. Here's n equals 7. So if I expanded Pascal's triangle all the way to n equals 7, here are my values that I want to use these. And these values are going to mean something else in a few minutes. Here is my number that I'm taking it by. Here's my values of r. When I'm doing 7, choose 0. 7, choose 1. 7, choose 3. Here's 7, choose 5. 7 taking 5 at a time. See that the answer is also going to be 21. Now, triangle is nice and easy to work with as long as our numbers are relatively small, but you're not going to want to draw a Pascal's triangle that has 47 levels to it. So keep that in mind. The formula works all the time. Okay. The next piece is called the binomial theorem. The rule says this: if I have a binomial, a plus b, to any power, I can use this rule right here that says whatever n is, that exponent, that's our degree, choosing 0 at a time, I'm going to have a to the n, the first term to that exponent, b to the 0. And anything to the 0 power means 1, so that's not even going to be there. And then I just keep working this all the way until I get to n choose n. So I have n items choosing 1 at a time. Notice what happens here. A to the n becomes a to the n minus 1. B to the 0 becomes b to the first. So look for the patterns here. Then I got n choose 2, a to the n minus 2, b to the second. So the first term keeps going down from the degree of n, and the second term keeps going up from the degree of 0. And this keeps going until I get n choose n. At that point, a becomes a to the 0, which is just 1, and b now has the exponent of n. An alternate way of writing this would be the summation, sigma, when r is 0 to n, in other words, 0 to n, of a to the n minus r, b to the r. So, in this case, when r is 0, I got n minus 0, which is why this was n. R is 0 in the first term. This is why this is b to the 0. And then we do for r equals 1, which is this term right in here. Then we do it for r equals 2, which is this term right in here. And we keep doing that until r is equal to the value of n, which is this last term right here. This again is in the formula booklet. It's called the binomial theorem. Keep that in mind. And let's take a look at an example. So it gets a little busy looking, but a plus b to the 4th power. I'm just going to use the rule. And the rule basically just tells us what to write. So starting with this term right here, I have 4 r is 0, right? 4 is my exponent. So 4 choose 0. Notice that this is a to the 4th, b to the 0. Notice what happens in the next term. 4 choose 1. I reduce the first term by 1. So a to the 4th now becomes a to the 3rd. At that point, b to the 0 becomes b to the 1st. Okay, so we have all that. Let me get rid of all this extra stuff up top here. Just do this with the mouse again. So 4 choose 1. I subtract 1 for my new exponent for the first term. I add 1 to get my new exponent for the second term. And that's kind of spelled out down here. The first term a decreasing from n, and the second term b is increasing from 0. If you look all the way across, 4 choose 2. I go down 1 for a, up 1 for b. 4 choose 3, down 1 more for a, up 1 more for b. 4 choose 4, a to the 0, b to the 4th. And then I just simplify these things. Now, here's Pascal's triangle again, and here's the row for n equals 4. This is n equals 0, 1, 2, 3, 4. Look at my coefficients, 1, 4, 6, 4, 1. They match Pascal's triangle, 1, 4, 6, 4, 1. A to the 4th, this becomes 1, so we don't need it. So 4 choose 0. So 4, that's the n equals 4. R equals 0 is this term right here, of 1. So this becomes my coefficient. So Pascal's triangle helps us find these coefficients quickly and easily. 4 choose 1. So n equals 4, r equals 1. The answer is 4. So on and so on and so on. So we can do all these things. If I look at the next one, 4 choose 2. So here's n equals 4. Here's 2. The answer is 6. so on and so on. And then we just simplify things, and here's my final answer. Okay, and we're just going to keep looking at examples so you get the hang of what's going on here. We're going to do a different example. Instead of a and b, we're going to use x and 3 instead of a and b. X plus 3 to the 5th power. Here's the expansion. My exponent is 5, so I start out with 5, choose 0. First term is x, so that's x to the 5th, x to the n. And then the second term is 3, 3 to the 0. Notice what my x's do. X to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. Notice then what my second term does. My second term goes 3 to the 0, 3 to the 1st, 3 to the 2nd, 3 to the 3rd, 3 to the 4th, 3 to the 5th. Woo. That was crazy. 3 to the 5th. So that's basically the setup. And then all you got is 5 choose 0, 5 choose 1, 5 choose 2, 3, 4, 5. And you can do this a couple of different ways. You can use the formula, or you can write out Pascal's triangle so that you can see where you should be at that point. Okay, so I'm just going to cheat and go over here. If this was 4, then n equals 5 would be 1, 5, 10, 10, 5, and then 1 again. So I wrote that on the side here. Here's n equals 5. Here's my r's, 0, 1, 2, 3, 4, 5. And now I know what my numbers should be. So it should be 1. This part right here, 5 choose 0 is 1. X to the 5th, 3 to the 0 goes away. Here's my next coefficient. So basically I'm just writing them in here. I got 1, 5, 10, 10, 5, 1. Those are my coefficients found from that line. X to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0 is no longer necessary. Then I got 3 to the 0 is 1, that's gone. 3 to the 1st, 3 squared is 9. 3 to the 3rd is 27. 3 to the 4th is 81. 3 to the 5th is 243. So everything is all lined up. I just simplify it a little bit more, and I end up with this answer at the bottom. Okay, use the binomial expansion. Now I changed this a little bit. I put a minus sign in here this time. Okay, so I got a minus sign, which has to stay with that term. And then I'm just going to do the same thing. Right here is my n equals 3. Here are my values of r, which means 3 choose 0 is 1. 3 choose 1 is 3. 3 choose 2 is 3. 3 choose 3 is 1. So there are all my values. My first term is 2x, so I do 2x to the 3rd. Two x to the 2nd, 2x to the 1st, 2x to the 0. My second term is negative 3y, so I do negative 3y to the 0, negative 3y to the 1st, negative 3y to the 2nd, negative 3y to the 3rd. Now the only difference now is that we're going to get some terms that are negative. That's it, because of the negative 3y. I simplify each term, simplify it a little bit further, and I end up down here in the boxed answer. 8x to the 3rd. I got 3 times 4 times negative 3 is negative 36, x squared y. 3 times 2 is 6 times 9 is 54, xy squared. And then finally negative 27y to the 3rd. It's just a matter of understanding what the rule says and then applying the rule each time. Okay. Now, instead of writing out the whole thing, some questions just say find x to the third term in the expansion of 4x minus 1 to the ninth. So here's the solution. N choose R is going to be 9, because that's right here. Choose 6. Okay? Now the reason I said choose 6 is because I want to find x to the third. So since this is the term with x, I want this to be the term that has the 3 in it. Remember what the formula says. It says this: n choose r, a to the n minus r, b to the r. So 9 minus 6 is what's going to give me the 3. So you're just going to have to manipulate it a little bit so you get what you want. So I have n choose r, a to the n minus r, that's the 3, b to the r, which is 6. Using the formula, this is going to be 9 factorial over 6 factorial, 9 minus 6 factorial. Four to the third power is 64, x to the third. Anytime you put a negative to an even exponent, you get a positive. My final answer is going to be, now I just took a liberty here and said 9 times 8 times 7 times 6 all the way down. This is 6 all the way down, so I know 6 factorial up here and 6 factorial down here will eliminate. So I just left 987 over 9 minus 6, which is 321, and I simplified that, and I got 84 times the 64x to the third, and then the third term in there would be 5,376 x to the third. So instead of asking you to write the whole thing, sometimes it just wants a specific term. You just have to understand how to do this part right up here, which is part of that formula sheet again. Okay, last example. In the expansion, now this time notice that I didn't tell you what the exponent is, but I do tell you that the coefficient of x to the third is 80. So we know what the coefficient is going to be. We just have to work backwards to find that. Find the value of n. So looking at this, we have n, choose n minus 3. Now the reason I wrote n minus 3 is because we're looking for the x to the third term. If I was looking for x to the fourth term, I'd write n minus 4. My first term is 2x. Using that formula again, n minus r becomes n minus 3. What happens to the n's here? N minus n goes away. Minus a negative 3 becomes positive 3. And that's where this positive 3 comes from. And then my second term is a 1. So 1 to the r is going to be 1 to the n minus 3. Well, 1 to any power equals 1, so that made that pretty simple also. I'm going to simplify this a little bit. I still have n, choose n minus 3. 2 cubed is 8, x to the third. And they told us that the coefficient was 80 for the x to the third term. This was given in the question. So we just have to use that information. So I set this equal to what they said it's supposed to be, 80x to the third. Looking at this, I can expand this using the formula. N, choose n minus 3 is going to be n factorial over n minus 3 factorial times n minus 3 factorial. And this is distributed again, so n minus n goes away. Minus negative 3 became positive 3, and that's where that came from. On the right side here, I'm basically just simplifying. I divide both sides by 8x to the third. Everything goes away here. X to the third goes away here. 80 divided by 8 is where the 10 comes from. Taking it a step further, what does n factorial mean? It means n times n minus 1 times n minus 2 times n minus 3 times n minus 4. 3 factorial means 3 times 2 times 1. N minus 3 factorial means n minus 3. Subtract one more, n minus 4, n minus 5, and so on and so on. Well, what's going to happen here? Everything from this side on, all this is going to reduce with all of this. Those are all gone now. And simplifying this is 6. 3 times 2 times 1 is 6. So I'm going to multiply both sides by 6. This is where the 60 comes from. And I'm left with n times n minus 1 times n minus 2 equals 60. I'm going to start distributing all of this and bring the 60 back over to the other side. I have eventually n to the third minus 3n squared plus 2n minus 60 is equal to 0. Now, I'm trying to find the value of n. I can do factor by grouping here, most likely. But what I plan on doing instead is I'm just going to put this into a calculator. And I'm going to put this side of the equal sign as y1. This side of the equal sign is y2. I'm going to do the whole second trace, calculate, intersect, enter, 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 and I find out that they intersect at 5. So here's what I did on the calculator. I just did y1, y2. I hit zoom 6 just to start, zoom 6. So I got my graph. Here's my graph then. And at this point, I did second, trace, and then 5 for intersect. And basically, I found that they intersected at x equals 5. And that is the last lesson. Thank you.